Hi guys, this is Zainali and I am back with a new tutorial. This tutorial we will be discussing about the different types of the support, different types of the beam and different types of the loading. So guys, before beginning this tutorial, if you haven't yet subscribed to my channel, do subscribe my channel and click on the bell icon to get notification about the newly uploaded videos. So in this subject, we will be coming across the term as a beam. What will be coming is a beam. So let us first gain certain idea regarding the term as a beam. So beam may be defined as a structural element. Any structure, for let us consider this as a pen, as a structural element that is one dimension more as compared to other two dimensions. For example, if this length of this pen, if the length of the pen is more than the other two dimension, that is breadth and thickness. Let us say here it is circular cross section, instead of that it is a rectangular cross section. Then if the length, this is a length is more than the breadth and the thickness, then it may be regarded as a beam, but it has to be supported on the certain types of the support. Also, when this beam is resting on the support and the loading is applied in the vertical direction, the loadings are always applied in the vertical direction. However, it is not necessary that load are always applied in the vertical direction. It may be inclined, then we have to resolve it into two components as vertical and the horizontal. Now when this beam rests on the different types of the supports and we apply the loads in the vertical direction, then according to Newton's third law of the motion, the reactions are developed by the supports which act on the surface of the beam. For example, if we sit on the chair, then we apply the force on the surface of the chair. Similarly, the chair will apply the force on us. Like that only, as the load is applied, this beam will apply the force on the supports, due to which the support will apply the reaction back to the beam. Hence, for different types of the support, there are different types of the reaction. Hence, there is a need to understand the different types of the support. So the first type of the support is the simple support. So let us note down. So first type of the support is simple support. So what is a simple support? Let us consider, we would be considering this pen as a beam only for this tutorial. So if this rests simply on the support, then such type of the support is regarded as a simple support. Moreover, in this type of the support, the reaction at the support is normal to the surface of the beam. Okay, and the beam is free to move in the direction along its axis, means it is free to move in the horizontal direction. Actually, these reactions which are acting on the beam by the support will maintain the beam in the equilibrium position. That's why the reactions are acting on the beam. So here there is no horizontal reaction acting on the beam, hence the beam is able to move in the horizontal direction. Now it is also able to rotate as there is no resisting moment acting on this beam. There is only vertical reaction acting, there is no horizontal reaction, there is no moment acting on the beam. As the beam will be able to move in the horizontal direction, also it can rotate about its axis. Such type of the support is regarded as a simple support. Let us draw it simple support. So such type of the support is regarded as a simple support. Okay, it is shown by this manner only. Now another type of the support is a roller support. So when this beam rests on the roller, you have been visualizing it in the malls, in parking areas. The doors which are opening in this manner are supported on the roller. In such type of the support, there is only one reaction which is normal to the surface of the beam. Let us first draw it. The roller support. The roller support is indicated by two manner. In such a manner also, or it can be represented by this manner. Both are indicating the roller support only. In case of the roller supports, the reaction are always normal to the surface of the beam. As this is the surface of the beam, the reaction would be always normal to the surface of the beam. And there is only one reaction acting on it. Hence the beam is able to move in the horizontal direction, also it can rotate about its axis. Now another type of the support is a hinge support. This type of the support can be represented as like this. In such type of the support, the beam is neither able to move in the horizontal direction nor in the vertical direction as the beam is hinged at this point. Hence there will be two resisting reactions acting at a point. So let us draw the two reactions. Hence in case of the hinge support, there are two reactions acting which are normal to each other. Let us note it as RV. This is vertical reaction and this is the horizontal reaction. The resultant reaction would be acting at a certain angle of theta. So the magnitude of the resultant reaction R can be evaluated by R equals to under root of RH square plus RV square. Also tan theta is equals to RH divided by RV, where theta is the angle made by the resultant with the vertical reaction. Okay, such type of the support has two reactions, that is RH and RV at the support. Now next type of the support is fixed support. In fixed support, the beam is neither able to move nor rotate. Such type of the support is regarded as a fixed support. The example of this type of the support is the beam in our house or in any of the building. They are fixed at a point. They are neither able to move nor they can rotate about the support point. Hence there will be resistive moment also acting at this point. So there will be moment acting at this point. There will be also horizontal reaction acting and the vertical reaction also acting at this point. So such type of the support is regarded as a fixed support. So in case of the support, the only things to be remembered is the number of the reaction acting at the beam by the support. In case of the simple support, the number of the reactions are 1. In case of the roller support, the number of reactions are 1, which is normal to the surface of the beam. In case of the hinge support, the number of the reactions are 2. In case of the fixed support, the number of the reactions are 2 along with the moment 1. There is a 1 moment also acting at the support. Okay. Now the different types of the beams. These different types of the beam is determined on the basis of the different types of the support only. The first type of the beam is the simple supported beam. Simply supported beam. Now in this beam, both the ends of the beam are simply supported. Then such type of the beam are regarded as a simply supported beam. Okay, such type of the beam can bear the load normal to the axis, means the loads are applied in these directions, as we know. In case the number of the reactions would be equals to 2, as the single support will apply one reaction, the total reaction would be equals to 2. Now the another type of the beam is the beam with one hinged and one roller. So one hinged and one roller. This type of the beam is most used. So one hinged and one roller. As there are two reactions in hinge support and one reaction in roller support, the total number of the reaction will be equals to 3. Now the next type of the beam is the overhanging beam. What is referred as a overhanging beam? So if the beam is projecting beyond the support, first let us draw the support. We have two hinge support. Now what is overhanging beam? We know that if the beam is projecting beyond the support, till that it is the length of the beam is equal to the distance between the two support. But now if the beam is projecting beyond the support like this, then such type of the beam is regarded as an overhanging beam. It is not necessary that entire beam would be on the one side. It is also possible that the beam may be resting like this. Such type of the beam is also regarded as overhanging beam. In this, there are two reactions for each hinge support and the total number of the reactions are equals to 4. Now, another type of the beam is the cantilever beam. So, in this type of the beam, the one end is fixed and the other end is free. Such type of the beam is regarded as a cantilever beam. Okay, the total number of the reactions will be equals to 3. We will be considering moment as also kind of the reaction only, as the total number of the reactions would be equals to 3. Now another type of the beam is probed cantilever beam. So if one end of the beam is fixed and one end of the beam is hinged, then such type of the support, the such type of the beam is referred as a probed cantilever beam. The total number of the reaction would be equals to, there are 3 reactions here and 2 reactions here, therefore total reactions would be equals to 5. This type of the beam is used to prevent the deflection at the free end when the loading is applied. That will be discussing later on. But such type of the beam is used to prevent the deflection at the free end. As we know that if the loads are applied, then there would be the deflection taking place, the bending of the beam would be taking place. Now another type of the beam is both ends hinged. Here in this type of the beam, both the supports are hinge support only. Then such type of the beam is regarded as a both ends hinge beam. The total number of the reactions would be equals to 4. Now another type of the beam is continuous beam. So another type is continuous beam. So what is continuous beam? A beam is said to be continuous beam if it is supported at more than 2 points. For example, there are 2 supports like this. If more one support is provided, then such type of the beam is regarded as a continuous beam. Now another type of the beam is a fixed beam. This type of the beam, the both ends are found to be fixed. Such type of the beam is regarded as a continuous beam. Here if all the supports are the hinge support, then the total number of the reaction will be 2n, where n is the number of the supports. Okay, and in case of the fixed beam, the number of the reactions would be equals to 6. The maximum number of the reactions if the 2 supports are taken into consideration only. Now we will be considering the different types of the loading. So what are the different types of the loading? So first type of the loading is considered as a concentrated loading. This is also referred as a point load. For example, if this is a beam which we are taking into consideration, and if the load is applied at a point, then such type of the loading is referred as a point load. Actually it is not a kind of the point load, but the load is acting on a beam over a very small length, hence it is regarded as a point load, and it is acting at a midpoint of the length. Means if the span is 5 meter, then this point load would be acting at a distance of 2.5 meter from the either end, means at the center of this beam. Such type of the loading is referred as a concentrated loading. Generally there are different other 2 types of the loading, that is uniformly distributed loading and a uniformly varying load. Then these 2 loading has to be converted into the concentrated loading for solving the problem. So let us represent the point load or the concentrated load. As I have told that this type of the beam is most commonly used. Okay, this load W would be acting at a span of L/2 from the either end. Okay, if the length of the beam is equals to L. Now another type of the loading is uniformly distributed load. It is regarded in short as UDL. Okay, in this type of the loading, the load varies uniformly throughout the length from one point to the other point. Okay, Let us plot the load diagram as it is regarded as this. The uniformly distributed load is regarded by these means, or it may also be regarded as this, and many times they are also regarded like this. Okay, these are the symbolic representation of the uniformly distributed load. The magnitude is given by P kilonewton per meter. As the intensity throughout its length remains the same, the per meter intensity would also be same throughout its length. If the length is equals to L, then the total intensity of the load would be given as PL kilonewton. Okay, the total intensity of the load would be equals to PL kilonewton. Now, this PL kilonewton would be acting at a distance of, this PL kilonewton is again the point load only, which is the total load of the uniformly distributed load which is acting throughout its length. It means we have converted this UDL to the point load whose magnitude is given as PL kilonewton. This would be acting at a centroid of the beam, means at a center of the gravity. At this point, this PL kilonewton would be acting, which would lie at a distance of L by 2. Okay. If the length of the beam is 5 meter, and if the intensity of the load, uniformly distributed load, is 4 kilonewton per meter, and the span is equals to 5 meter. Okay, then the point load would be given as 5 into 4 kilonewton, which is equals to 20 kilonewton, which would be acting at a distance of 2.5 meter from the either end. Okay, so this is a method for converting the uniformly distributed load to the point load for problem solving purpose. Now the another type of the load is uniformly varying load. Uniformly varying load. It is regarded as UVL in short. Okay. So in such a type of the loading, the load varies uniformly from one point to the other point. I have told this type of the loading is uniform, but it's not true. In uniformly distributed load, the intensity of the load remains same throughout its length. That was my mistake. The intensity of the load throughout its length remains the same in case of the uniformly distributed load, but in case of the uniformly varying load, the load varies uniformly from one point to the other point. The load diagram can be represented as follows. So it will be more clear. The load intensity varies uniformly from one point to the other point. Here the load intensity is 0 and here the load intensity is maximum. It is also regarded as P kilonewton per meter only. The maximum intensity of P kilonewton is represented by this ordinate. Okay. Let us take this as a span L. How to convert this UVL to point load? Now as we can see that this is a right angle triangle which we are getting. So the area under the load diagram would be equal to that of the point load, which will be acting at a centroid of this load diagram. Okay, so the area of the diagram which is given as half into base into height. As I told, this ordinate represents the maximum intensity, that is P kilonewton. Therefore half into P into L, which is equals to PL by 2 kilonewton. Okay, this would be intensity of the load, point load, which we have obtained from the uniformly varying load. Now another point is that at which distance that load would be acting. So it would be acting at a distance of 1/3 distance from the bigger end, that is L by 3, and 2L by 3 from the shorter end. Okay, so this is the magnitude of the intensity of the point load, magnitude or intensity of the point load for a uniformly varying load which will be acting at a distance of L by 3 from the bigger end. Means this end it would be acting at a distance of L by 3, and from this end it would be acting at a distance of 2L by 3. So guys, that's all regarding the different types of the support, different types of the beam, different types of the loading. If you have any query regarding this, do comment in the comment section. Do like, share this video, and don't forget to subscribe my channel. Thank you guys for watching this video.